begin the session by showing the demonstration of the game that I have created. We'll boot it up here, just build it quick. So here we have our game running. All of the walls consists of the X's that you see, and there are also other chars present here, right? So we have in the rightmost corner, bottom rightmost corner, here moving up and down, that's us, the player, and the player is represented by the char O, and that's a capital O. Above us is a capital S, which represents a monster. Same applies for the char capital C, sorry. And the char capital B. The P and the T that remains are objectives in the game. The P is actually just a potion that recovers our health points, and we'll get to that shortly. And the T is the treasure that we have to pick up in order to win the game. Right below the maze we have a few statistics showing, the first of which is our name. We're called the Mysterious Traveler. Right next to that we have our health, equal to 12 at the moment, and we have our attack power, which is equal to 3. Right below that we have our controls, so we'll be using W, A, S, and D to move our character. As you can see here, they correspond to arrows. So let's get started. Alright, so we walked into a skeleton here, and it asks us if we want to fight or escape. We'll attempt the escape. And we succeeded. You see, he's gone now, and we're allowed to move on. Since we haven't lost any health, so we're not gonna bother with the potion yet. And we'll challenge the zombie this time. It's a bit stronger than the skeleton. Try to escape, and we succeeded. Means we can make it to the bus all safe and clear. Alright, so we're not allowed to escape from the bus, so we'll just have to fight our way through. And what happens here is, right below our stats, you'll see that there's one session going here. Through the first turn, our hero attacks, deals 3 damage, leaving the boss at 7 health. The boss returns, or retaliates, he deals 2 damage, and the hero's health is now at 10 health. And you can see here that it's been updated since the last log up here. So we'll fight for another session, and we'll strike first again. Exactly the same that happened. We're at 8 health now. The boss is at 4 health, so try to fight again, deal 3 more damage. He's now at 1 health, and we're at 6 health. Now we'll give the killing blow, and the boss is out of the way, and we're still left at 6 health. There we go, picked up the T, and see if we loot the potion here. We're back to 12, all's well, and we win the game. We left with the treasure in hand. Press enter to exit. And that concludes the demonstration of the game. So let's see how it's possible for us to make all that happen. Excuse me. Starting here from the very top, we'll be including 3 libraries to make everything go around. The IO stream is essentially just to control input and output, since we'll be using cout a whole lot to generate what you see in the command prompt. Moving on to conio.h, which is a header library that we'll be including. We'll be using a very specific a function from this header called the getch, which will be discussed later. And finally, we'll be using strings, so we'll include the method to do so from this library as well. Going on. To save me some time in the program, I'll be using the entire namespace standard, so I can cin and cout throughout the code without having to write standard and semicolon, or sorry, colon. Moving on, we have some global variables here. We have a char, which is the player, a as we saw, that's the capital O that we moved around with. We have that O's initial position in the grid. Here we have two integers that we'll be using to determine whether we succeed at escaping from an enemy. Will be used later. Both in two different functions, that's why we're declaring it here. And finally we have a boolean to estimate whether we are game over or not, in the negative sense that we've been killed by the enemies in the dungeon. Brings us, as the command here points out, to the layout of the maze. What you see here is a two-dimensional array consisting of chars, or there's chars in the array, since the array can only take indexes of the same data type. We'll have to declare which right here. And what's contained in all these indexes in our two-dimensional arrays is all these chars, which makes out the layout of the maze. The comments up here is just for quick reference when I had to write the code to know which location I'm working with and checking on and so on. So it makes it easier to say, like, right, where's this skeleton located, for instance? He's located at 9.10. So it makes it a whole lot easier this way. Well, I'm using 3 functions. This is the first one, which I actually made last. What this does is that it changes the value of our game over boolean. It prints out to the command prompt that the hero has fallen, and it pauses the entire game so that we can no longer do any inputs once the game is over. And that concludes the first function. The second function, MazeGen. This is where everything interesting happens. Basically, the grid we have up here is printed or generated within this function. The first thing we do every time we make a function called to MazeGen is to clear the command prompt, and that's what happens here in order to update, to make the map dynamic and sort of pretend that our game is updating at a live rate, which of course it's not. It's just being printed out to the command prompt. This right here is used to determine whether we can escape or not. What happens is that every time MazeGen is run, a random number with modulo 10 plus 1 is generated. That means that we get a number from 1 to 10. 0 to 9 actually. That's why we have the plus 1, so that we don't get 0. So we get 1 to 10 with the plus 1. And I'll be using this later to determine whether the value generated by this is high enough to allow the escape. The reason I am doing this is that I want, every time I run this MazeGen, I want the escape factor to update, so that every time we run into a monster it's a new number that we have, which we don't know. So pseudo-random chance to escape. Here is the position of our player in the grid, because every time we update the grid we also want to know where our player is located. The player will be starting here, so it'll be run here, and we take coordinates in our array and assign the O, the capital O char, to be placed in that coordinate, you can say. Going into a for loop and a nested for loop here. This one will be generated integers to the variable j, going from 0 to 19, which corresponds to 0 to 19 on one axis of our grid. Sorry. And we'll be printing out, or we will be inserting to a new line every time this for loop is run, so that's 10 times total. But inside we have also a nested for loop, which will be generating the actual maze. And every time this for loop, the other one, runs or iterates, the nested for loop will be iterated 10 times. Or, sorry, 20 times. We have our integer going to just below. And once this function call has been called, or sorry, when this function has been called, and its body has been executed, we'll be having a map such as this one, as we saw in the when I demonstrated the program. So what just happens is that it runs once with the value 0, so that's the coordinate in the two-dimensional array. The same happens here, the other coordinate. And as long as the integer going through a for loop is less than 20, this will happen, and we will increment by 1 every time it's iterated. So that pretty much means that the nested for loop will be generating these, while the outer for loop has run just once. Then the outer for loop will run the second time, and the nested for loop will generate 10 again, 10 again, 10 again, 10 again, 10 again. Also, both of them have been iterated a maximum number of times as specified by the integers, generating our map. That concludes our second function. Going into our third function, called main. Our main function, our doorway into our program, so to speak. What happens here is that if you go back in the video, you'll notice that I'm having alternate colors in our command prompt. Instead of the generic black background with the white characters, I'm using a blue background with a sort of greenish color for the characters. It's just a little something I added. I wanted to add specific colors to the different characters, so that the player's character would have a certain color and it would have a certain color for enemies. But it would seem that I would have to include some libraries in order to do that, and I couldn't really find out just how with the time I had to make this exercise to actually make that happen. So I went for the alternative here. So down here we'll be having a struct, a structure data type called stat. It'll be having the variables we'll be using for enemies, and the struct we'll be using for our hero is the one called player struct down here. So we declare our struct. We go into the body, assign some variables. It will be accessing right down here. Here we create one for the bottommost struct right here, and we'll name it hero. And we'll be assigning values to our hero based on what we are allowed to assign from here. So we know that we can set our health points, our maximum health, so it could be current health and maximum health. Sorry. And our attack, as well as the name of our character. And that's what happens here. Now the values are being assigned. Same happens to our enemies. We have the zombie. Again, notice the C that represented him in the game. And the skeleton, the S, and the boss, the B, the final one that we fought before getting the key. And down here, once our program executes, everything in the main scope will be executed at least once. And we want a layout of the maze to be shown when this happens. So that's why we have a function call to generate a map from one of our different functions that I just went through. Then we have 4 Boolean values. The first one, win condition. When this one equals true, we'll break out of our while loop. That's just down here. And the while loop pretty much controls the entire flow of the game. We have a Boolean here, picked up. This one evaluates whether we have picked up the treasure. And that's important because this one is actually determined, or this one has to be true before the game can be completed. So without this one, you'll never be able to finish the game. Down here, this one is used to evaluate whether we're in combat or not. and this one is to prevent people from being allowed to try to escape from a monster that they have already failed to escape against more than once. So they will have one try for each monster. So that's what this boolean value is for. Going down here, there's a comment here. So, as long as the game has not been won yet, and we're not game over, the game flow is allowed to continue. Then, our while loop checks, are we in combat? And if we are, as you see here, we'll have some output here. This one is our statistics, showing us our condition, our name, our primarily the important factors, our health and our attack. This one down here tells the player the controls during battle. Do you want to fight or escape? Press F or E. And that's only relevant if you are in combat, so that's why we check for that. If we're not in combat, then that means we're in control mode. That is, we're allowed to move. So the controls are told, again, in similar manner. And every time that our while loop runs through this, that means we have taken a move action. We want to update the map, so that's why we generate one here. Going out of this, here's the catch that I talked about. This pretty much records the last input that the user have made on the keyboard. That means that when you're asked, do you want to fight or escape, you either press F or you press E. If you press F, the battle system will initialize. And we'll get back to this content in a moment. However, if you press escape, let's find it, just down here. This else is connected to the F up there, determining whether we press F or not. It will set a value based on the random that we generated, and will then check if that value is less or equal to 5, and if we're allowed to escape. If so, it'll say that we have escaped, and that we're no longer in combat because we escaped. If this roll fails, that means that it's bigger than 5. It will say that we cannot escape, and of course it won't allow us to escape either. So this will never be executed again because now it's certainly false. And this value won't be reset until you fight the monster and win, or you end with a game over and everything's over anyway. So let's return up here. Right, going in here to our first if. It determines the location that we are on. If these coordinates are the locations, or sorry, the coordinates that the player is located on, this combat sequence will be initialized. And 3.1 or 1.3, depending how that's 1.3, yeah. 1.3, that's the boss, so that's how it works, right? Returning here, a battle sequence, a cout telling you what happens, then an actual, oh, it happens over here, sorry. We'll be taking a value equal to the attack of the hero from a value that's equal to the health of the boss. So in this case, the hero has 3 attack, and I know that the boss has 10 health. That means the boss's health is now 7, and that concludes the hero's turn. There we go. What happens here? This one just tells us what happens without it actually happening, and right after that, actually, this procedure is actually executed. And then we check if the boss's health is less or equal to 0. That is he dead? If he is, in combat, set back to false. And we reset the value. This instance, this is redundant since we don't have any more boss mobs in the maze. But with the skeletons and zombies, this is relevant because we don't want the next skeleton we run into to have a spawn at 0 health. So that's why this is here. Sorry. Going into our else, if this is the else is executed within this if scope. Sorry. And this is just a boss sequence. Like we attack the boss, took some of his health points, and he will do the same to us. With the printed out here, telling you what exactly happens, and this is what exactly happens. We'll take the health of our hero, deduct the attack points of the boss, and set it to our hero's current health. If our hero's current health is less or equal to 0, that is, he's dead, we'll clear the command prompt and we'll re-execute the game over function. We'll call it. And exactly the same happens here, just in the scenario of a skeleton. And the skeleton's turn, and the hero's turn, and another skeleton at a different location than the one above it. And again, the hero's turn, the skeleton's turn, still no new code. Now, for a zombie, the hero's turn, and the zombie's turn. And again, so the hero's turn, zombie's turn, and the final mob we have, the skeleton, hero's turn, and then the skeleton's turn. Now, once these sequences run, we've already been through this one with the escapes, we'll just pass that through. We'll get out of combat and we'll get to the other of two stages, that is either to be in combat or to be allowed to move. In exploration mode versus battle mode, so to speak. And this is where this else is connected to the if that asked if you were in combat. So, going into the exploration mode, we have a switch case, or switch statement, sorry, that evaluates on my input, which was the variable that was connected to the getch. So, the current character held in our getch is at a W. If so, take the current position of our hero in the maze, and put a blank spot there, then evaluate if the current position that you're standing at -1, that means that the position just above him is not an X, so that's not a wall, then do the actual movement. And this one is a special case and it's only used here, and that's used to evaluate whether the spot, the coordinates 1.1, which is the T, the treasure, if we're on that spot, that means we're picking up the treasure, so that's why we're assigning that one to true, since the only place where this can happen is at this spot, so we can do it like that. And then we'll be evaluating the current position. If the current position of our hero in the grid is not a blank spot, and the current position of our hero is not the treasure, then we must be in combat. And what this says is that if the space that we're trying to move to, if that space is not blank, that means that it's a legit path to walk on, and if it's not a T, then it must either be a P, the potion, a Z, a zombie, a skeleton, or the boss. In either of these cases, with the exception of the potion, and we'll be having a script that prevents the potion from being fought later on. It could have been here, but it's included later on. So just forget about the potion and think about the creatures. Then we're going to be in combat because it has to be a creature, and then it says that we're allowed to escape as combat begins. and then we go out and we break. And the break is important because, or else the cases will all be run. So we have to tell our compiler that this is where this case ends. So if in case my input is W, only execute this and then stop here. Going into S, it works pretty much similar. The direction is just downwards instead of up. So that's why we'll be adding 1 instead of like above, subtracting 1. And again, it evaluates. But here there's a special case too, because the beginning location when the game starts is also the location where you win. However, if you're on this location and you have picked up the treasure, then the win condition is true and you win the game. However, you start at it and the picked up condition is false, so this won't be run before you've actually gone and picked up the treasure. So instead, or moving on, we have a similar code here that evaluates whether what we've encountered is a monster. Breaking. This time we'll be moving on a different coordinate, and what you have to notice right here is that when we want to move up and down, we're actually moving on the variable called x position p, which is wrong. It should have been y position p, and that's all fine if we're just aware of it. But I want to note that when it says x position p, it's actually along the y-axis that we're moving. So now we know that when it says x position p plus equals 1, that means we're moving on the x-axis. That corresponds to D on your keyboard, and that's moving right. But the rest is the same here. But here we have it checking for the p. So, and since we weren't checking for the p with the case of W and S, is because, scrolling up, we'll return to the code in a moment. I just want to visualize this. The P is located here. The only way to get to this P is by standing on this spot and then moving right. So there's no point to check whether what we're encountering is a P when we're moving up, left, and down, because that can't happen. And that's why, as I said earlier, I would explain it. So we'll return. Moving down here, I just have to spot it. There it is. So if it is a P, that means that if it's not a blank spot, and it's not a T, and it's not a P, then we're in combat for the case of D. However, if it is a P, then restore the current health to the maximum health. That means that we can go from 1 health at the minimum to back to 12 health, no matter what our current health is. So that's just a healing to make the game a little easier. And then we have the case of A. And there's nothing new here. It works exactly the same way. And that brings us to the end of our program. And all of this coming together creates a primitive, yet somewhat functional dungeon crawling game.